Okay, hi everyone, welcome to this video series on the Cisco ASA firewall. Chapter 4, Controlling Network Access, Packet Filtering. The Cisco ASA can protect the inside network, the demilitarized zones, DMZs, and the outside network by inspecting all traffic that passes through it. You can specify policies and rules that identify what traffic should be permitted into or out of an interface. The security appliance uses an access control list to drop unwanted or unknown traffic when it attempts to enter the firewall. The Access Control List ACL is a collection of security rules or policies that allows or denies packets after looking at the packet headers or other attributes. Each permit or deny statement in the ACL is referred to as an access control entry, ACEs. These ACEs can classify packets by inspecting layer 2 through layer 4 headers for a number of parameters, including the following: layer 2 protocol information such as EtherTypes, layer 3 protocol information such as ICMP, TCP or UDP, layer 3 header information such as source and destination IP address, layer 4 header information such as source and destination TCP or UDP ports. After an ACL has been properly configured, you can apply it to an interface to filter traffic. The security appliance can filter packets in both the inbound and outbound direction on an interface. When an inbound ACL is applied to an interface, the security appliance analyzes packets against the ACEs after receiving them. If a packet is permitted by the ACL, the firewall continues to process the packet and eventually passes the packet out the egress interface. If a packet is denied by the ACL, the security appliance discards the packet and generates a syslog message indicating that such an event has occurred. In Figure 4.1, the security appliance administrator has applied to the outside interface an inbound ACL that permits only HTTP traffic destined for 209.165.202.131. All other traffic is dropped at the outside interface by the security appliance. As you can see here, Figure 4.1, inbound packet filtering. So if an outbound ACL is applied on an interface, the security appliance processes the packets by sending them through the different processes NAT, QoS, and VPN, and then applies the configured ACEs before transmitting the packets out on the wire. The security appliance transmits the packets only if they are allowed to go out by the outbound ACL on that interface. If the packets are denied by any one of the ACEs, the security appliance discards the packets and generates a syslog message indicating that such an event has occurred. In Figure 4.2, the security appliance administrator has applied to the inside interface an outbound ACL that permits only HTTP traffic destined for 209.165.202.131. All other traffic gets dropped at the interface by the security appliance. Following are some of the important characteristics of an ACL. When a new ACE is added to an existing ACL, it is appended to the end of the ACL. When a packet enters the security appliance, the ACEs are evaluated in sequential order. Hence, the order of an ACE is critical. For example, if you have an ACE that allows all IP traffic to pass through and then you create another ACE to block all IP traffic, then the packets will never be evaluated against the second ACE because all packets will match the first ACE entry. There is an implicit deny at the end of all ACLs. If a packet is not matched against a configured ACE, then it is dropped and a syslog with message ID of 106023 is generated. By default, you do not need to define an ACE to permit traffic from a high security level interface to a low security level interface. However, if you want to restrict traffic flows from a high security level interface to a low security level interface, you can define an ACL. If you configure an ACL to a high security level interface to a low security level interface, it disables the implicit permit from that interface. All traffic is now subject to the entries defined in that ACL. An ACL must explicitly permit traffic traversing the security appliance from a lower to a higher security level interface of the firewall. The ACL must be applied to the lower security level interface. The ACLs extended or IPv6 must be applied to an interface to filter traffic that is passing through the security appliance. You can bind one extended and one EtherType ACL in each direction of an interface at the same time. You can apply the same ACL to multiple interfaces. However, it is not considered to be a good security practice. You can use ACLs to control traffic through the security appliance as well as to control traffic to the security appliance. The ACLs controlling traffic to the appliance are applied differently than ACLs filtering traffic through the appliance discussed in the box traffic filtering section. When TCP or UDP traffic flows through the security appliance, the return traffic is automatically allowed to pass through because they are considered established and bidirectional connections. Other protocols such as ICMP are considered unidirectional connections, and thus you need to allow ACL entries in both directions. There is an exception for the ICMP traffic when you enable the ICMP inspection engine. Types of ACLs. The security appliance supports 5 different types of ACLs to provide a flexible and scalable solution to filter unauthorized packets into the network. Standard ACLs, extended ACLs, IPv6 ACLs, EtherType ACLs, Webtype ACLs. Standard ACLs. Standard ACLs are used to identify packets based on their destination IP address. These ACLs can be used in scenarios such as split tunneling for the remote access VPN tunnels and route redistribution within route maps. These ACLs, however, cannot be applied to an interface for filtering traffic. A standard ACL can be used only if the security appliance is running in routed mode. In routed mode, the Cisco ASA routes packets from one subnet to another subnet by acting as an extra layer 3 hop in the network. Extended ACLs. Extended ACLs, the most commonly developed ACLs, can classify packets based on the following attributes: source and destination IP address, layer 3 protocols, source and/or destination TCP or UDP ports, destination ICMP type for ICMP packets, IPv6 ACLs. An IPv6 ACL functions similarly to an extended ACL. However, It identifies only IPv6 traffic passing through a security appliance. EtherType ACLs. EtherType ACLs can be used to filter IP and non-IP based traffic by checking the EtherType code field in the Layer 2 header. IP-based traffic uses an EtherType code value of 0x800, whereas Novell IPX uses 0x8137 or 0x8138, depending on the network version. An EtherType ACL can be configured only if the security appliance is running in transparent mode. Like all ACLs, the EtherType ACL has an implicit deny at the end of it. However, this implicit deny does not affect the IP traffic passing through the security appliance. As a result, you can apply both EtherType and extended ACLs to each direction to an interface. If you configure an explicit deny at the end of an EtherType ACL, it blocks IP traffic even if an extended ACL is defined to pass those packets. Webtype ACLs. A Webtype ACL allows security appliance administrators to restrict traffic coming through SSL VPN tunnels in cases where a Webtype ACL is defined but there is no match for a packet. The default behavior is to drop the packet because of implicit deny. On the other hand, if no ACL is defined, the security appliance allows traffic to pass through it. Comparing ACL features. Table 4.1 compares the various types of ACLs and specifies whether they can be used in conjunction with supported features on the security appliance. So you can see here, Table 4.1. Configuring traffic filtering. Access control lists on a security appliance can be used to not only filter out packets passing through the appliance, but also to filter out packets destined to the appliance. This section discusses ways to set up the appliance for packet filtering. Thru-Traffic Filtering via CLI, Thru-Traffic Filtering via ADSN, to the box traffic filtering, IPv6 traffic filtering. Thru-Traffic Filtering via CLI. Thru-Traffic Filtering refers to traffic that is passing through the security appliance from one interface to another interface. The configuration to filter packets through the CLI in a security appliance is completed in 2 steps. Set up an ACL and apply an ACL to an interface. Step 1. Set up an ACL. As mentioned earlier, an access control list is a collection of access control entries. When new connections try to pass through the security appliance, they are subject to the ACL configured on the interfaces. The packets are either allowed or dropped based on the configured action on each ACE. An ACE can be as simple as permitting all IP traffic from one network to another, to as complicated as permitting or denying traffic originating from a unique source IP address on a particular port destined for a specific port on the destination IP address in a specific time period. You define an ACE by using the access list command. You can define an extended ACL, an IPv6 ACL, or an EtherType ACL for filtering through the box traffic. The access control list arguments may appear complicated at first, but are fairly simple when you start implementing them in a lab or production environment. They not only give you full control over how you want to inspect traffic, but also provide you full logging capabilities in case you want to analyze traffic flow later. In figure 4.3, Secure Me, the fictional company used in examples throughout this book, hosts a web server and an email server at its location in Chicago. One web server, 209.165.202.131, allows traffic on port 80 HTTP, whereas the email server 209.165.202.132 allows traffic on port 25 SMTP. The security appliance allows only two client hosts, 209.165.201.1 and 209.165.201.2 to initiate the traffic. All other traffic passing through the security appliance will be dropped and logged. Example 4.1 shows the related configuration. An extended ACL called outside access is set up with 4 ACEs. The first two ACEs allow HTTP traffic destined for 209.165.202.131 from the two client machines, whereas the last two ACEs allow SMTP access to 209.165.202.132 from both machines. Adding remarks to an ACL is recommended because it helps others to recognize its function. The system administrator has added this is the interface ACL to block inbound traffic except HTTP and SMTP as the remark on this ACL. Step 2. Apply an ACL to an interface. After configuring an ACL to identify traffic allowed or denied by the security appliance, the next step is to apply an ACL to an interface in either the inbound or the outbound direction. Apply the ACL by using the access group command followed by the name of the ACL as shown in the following syntax, as you can see here. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.